Hello class, this is a video tutorial on the absolute value function. In this video we'll be looking at the general shape, domain, range, and doing a few sketches of the function. So absolute value x can be thought of as the distance or magnitude from 0. So for example, if we had absolute value 3, the distance from 0 to the point 3, well, that's just 3. The distance from 0 to negative 3, because absolute value of negative 3, because distance cannot be negative, this distance has to be a positive value. So the distance from 0 to negative 3 is 3. So I hope you can understand that it doesn't matter what value goes into the absolute value. It's looking at the distance from 0 to that value. So from 0 to that value. So there should be negative x here. Okay? Always going to be a positive value. It can also be thought of as a function with two components. So if x is greater than 0, we substitute x. If x is less than 0, we substitute negative x. So for example, if we had f of 3, 3 is greater than 0, so we use this component. So this just becomes 3. If we had f of negative 3, because negative 3 is less than 0, we have to use this component. So we put negative of negative 3, giving us positive 3. So if we had positive h, f of positive h, because that's greater than 0, this just becomes h. And because if we substitute negative h is less than 0, this becomes negative of negative h, giving us positive h. So either way, f of x equals absolute value x is viewed. It can be seen f of x is greater than 0 for all real x, because no matter what value we put in, it always becomes positive. As a result, this is what the graph looked like. If we had 2, it becomes 2. If we had f equals f of negative 2, well, that becomes positive 2. As a result, it becomes this sharp turn, and it is symmetrical about the y-axis. So it has a vertex also at 0, 0, this point here in blue. As I stated, it's symmetrical about the y-axis, meaning this point here is the exact same as this point here. It's symmetrical, much like the parabola. And its range is y is greater than 0. It's actually just whatever value this vertex is, because the lowest y value is at 0, and the y values only go up to positive infinity. Okay, so let's do a few examples here, and we'll sketch them using the intercepts and features of an absolute value function. We'll take note of where the vertex is. Here we go. So let's find the y-intercept first. The y-intercept, x is equal to 0. So we substitute f of 0 becomes 0 minus 3, absolute value. Negative 3, absolute value, becomes positive 3. So my y-intercept is going to be at 0, 3. My x-intercept, my y value is going to equal 0. So in this case, we let the entire function equal 0. So the function is absolute value x minus 3 is equal to 0. Solving this, we get plus or minus x minus 3 is equal to 0. And hope we can see. Actually, hang on, let me make some more space for myself. Hope we can see that even if we take the positive or minus, we will get an x minus 3 is equal to 0. X equals positive 3. So my x-intercept is at 3, 0. Graphing this out, let me just grab, oops, let me just grab a coordinate plane here. Here we go. So substituting and graphing these points in, we get 0, 3. 0, 3 is my y-intercept, so 0, 1, 2, 3. This point here. And 3, 0. So 1, 2, 3, 0. So far, that is my graph. But because everything has to be positive, we know that these values here cannot go below the x-axis. And because it's symmetrical about the vertex, there's a point of symmetry like this. The points here should be the exact same on the opposite side of the vertex. So we should have a graph that looks something like this. Graphing my points, that's going to be 0, 3 and 3, 0 at this point, vertex here. Let's do this one more time. Let's take a look at absolute value x, and then we minus 2. So let's find the y-intercept first. Whoops. We know that x is equal to 0. This will give us 0 minus 2. This will give us, well, that's 0, negative 2. That's just negative 2. Our y-intercept is at 0, negative 2. My x-intercept is going to be at y is equal to 0. So we let the entire thing, x minus 2 is equal to 0. Solving for this, we get x equals 2, like this. Now the absolute value, we get positive, or minus x is equal to 2. We get two x-intercepts here. We get x is equal to positive 2 and x equals negative 2. Okay, let's take a look at what this would look like. Let me manage this size for a bit. There we are. So my y-intercept is at 0, negative 2, 1, 2. And my y-intercept is at positive 2. Positive 2, so it's going to be here. And negative 2, which is going to be here. Whoops. Graphing this out, we get this function here. This point is at negative 2, 0, positive 2, 0, 0, negative 2. Now, combining these two graphs, notice how we have x, absolute value x minus 3, absolute value x, and then minus 2. If we combine the two, can you imagine where this will be? Without even having to graph what this looks like, without even having to determine where the x and y intercepts are, we can see from our previous videos on transformations, it's going to be the exact same graph as this, moved 3 spaces to the right. Or it's going to be this graph moved 2 spaces down. So just quickly graphing this out. oops, we can graph function of h, this one here, very quickly, just by viewing and looking at these previous two graphs here. So it's going to be at 3 minus 2. So we know our vertex is going to be here. So 3 minus 2. This space here is going to move 3 spaces to the right. So it's going to be at 1, 2, 3. It's going to be at 1. And this point here should be 1, 2, 3. It's going to be at 5. So 1, 2, 1, 2. It's off our graph here. So just graph what we can. It'll look something like this. This point here being 1, 0. This point here being 0, 1. And this point all the way off to the right should be 5, 0. So I hope that gave you an insight into the appearance of the absolute value function, as well as how to graph it using the points, the x and y intercepts, as well as the symmetrical feature of the graph itself. Hope to see you in the next video. Best of luck.